My name is Bright Moses. Today I want to take you through longitudes and latitudes. And first of all, we shall consider location of points on the surface of the Earth. We normally locate points using coordinates in form of latitude, then longitude. Like we can have a latitude, then longitude. And latitudes are normally imaginary lines which run from west to east, and they normally indicate how far the north is from the south or how far the south is from the equator. They are normally denoted using letter N or letter S. Like you can have point A, 30 degrees north or even south. So if you see a number with a north or a number with a south, that one is a latitude. Then you can have a comma here, and then a longitude can be like 65 degrees. But with longitudes, we normally indicate using either east or west. So we can say maybe this is east. So this is an example of how we can locate, how we can give the position of a point using the coordinate of longitudes and latitudes. Then to represent this one on a globe or on the surface, we normally draw a spherical globe like that, although it's not very perfect. Then the equator is imagined to be here at 0 degrees, like that. Any line that is drawn to the north of the equator will be represented using capital N, that's the north. And any line that is drawn to the south of the equator will be represented with an S here, meaning south. So, like this point, we shall represent approximately 30 degrees, right here 30 degrees north. Then, if it was to be south, we shall represent it here 30 degrees south. Then this is 5 degrees east. The prime meridian is normally here, and the prime meridian is normally 0 degrees. So if you are moving to the right of the prime meridian, any longitude to the right will be eastwards, and any longitude to the left will be westwards. So this is 5 degrees east will be on this side, meaning that we shall draw like that. Then we can indicate here 65 degrees east. So where the 30 degrees north and 65 degrees east meet this point, this is our point A. That's how we locate, that's how we present points on the globe. Now, if we had another point, maybe a point B, 30 degrees north, comma, 80 degrees west. Then on the same globe, this is how we are going to represent it. 30 degrees north is this one. Then 80 degrees west will be on this side. So we indicate 80 degrees approximately there. So if this is our 80 degrees west, then where the two lines are meeting, 30 degrees north, 80 degrees west, this is our point B. So that's how we normally represent points on the surface of the earth on globes. Now, in our next section, we want to see how you can calculate distance along a small circle. But before we do that, I want you to know that all latitudes are small circles, except the equator. The equator is the only great circle, but all other latitudes are small circles. So like this line is a small circle, this is a small circle. Any line in between here or in between here will be a small circle, but this is a great circle. So this is the formula for distance along a small circle. Theta divided by 360 times 2 pi r cos alpha. And this theta, if we are talking about the distance from B to A, then the theta will be the longitudinal difference between this point and this point. So if the two points are on different, or they are on the opposite sides of the prime meridian, we shall add the values of the angles. In this case, theta will be like between A and B. Okay, let's say for A, B, theta, we shall take the longitude for this value, which is 80. We add the longitude for this one, which is 65. And this will give us And our alpha in this case is the latitude on which the 2 points are situated, i.e. alpha here will be 30 degrees. So this formula shall have AB or BA as theta 145 divided by 360 times 2. If we take our pi to be 3.142, then it's 3.142 times R is normally the radius of the Earth. The radius of the Earth is normally 6370 kilometers. That one we shall multiply by cos alpha. Our cos alpha is now cos 30 degrees. Now when you press the calculator, you'll get your answer here in kilometers. That will be the distance from B to A. So remember, we have said that distance along a small circle, we use theta over 360 times 2 pi r cos alpha, where r is the radius of the Earth and alpha is the latitude on which the two terms are situated. This theta, if the two terms are on the same side of the prime meridian, if the two A and B were on the west, we get theta by subtracting the angles or the values. But if A and B are on either sides or opposite sides of the prime meridian, we add. Finally, let's have a look at calculation of distances along a great circle or along great circles. All longitudes are great circles. All longitudes are great circles. Any line that runs from north to south is a great circle, and the distance is normally calculated using theta over 360. Theta over 360 times 2 pi r. Our theta will be the latitude difference. Our theta will be the latitude difference. Now let us consider this sketch where let us consider this sketch where we have 2 points. Like if this is A, this is B, this is C, and this is D. Now let's allocate this as 70 degrees north, 60 degrees south, and this is 110 degrees, of course, west. This is 70 degrees east. Assuming that you want to get the distance from A to D, you see these are along a great circle. We are moving along a great circle, and from B to C, we are also moving along a great circle. But from A to B, these are small circles, these are small circles. So if we wish to get the distance from A to D, then the latitude is changing from 70 to 60. And remember, the equator is here in between at 0 degrees. So we are changing from 70 to 0, then from 0 to 60, which means the value of theta will be 70 plus 60. So this formula will become 70 plus 60 is 130. So we shall take 130 out of 360 times 2. Let's take our pi to be 3.142. Theta over 360 times 2 pi r. R is the radius of the Earth, which is 6370. And when you press your calculator, you get your answer here in kilometers. If this town A and D, here we were considering distance AD. If this town A and D were on the same side of the equator, like if this D was somewhere here, then we could have that. So if they are on the same side, of course this will not be more than 70. This is 0. This could be around 30 degrees north. So we are going to get the value of theta by subtracting 30 from 70. If they are on the same side, we subtract. If they are on either side of the equator, we add the two values of the angles to get the value of theta. So That's how the distance is supposed to be obtained. So remember what we have said is that distance along a great circle and distance along a small circle are supposed to be calculated in two different ways. Along a small circle we have this cos alpha, and along a great circle we don't have the cos alpha. That's what we have, what we are supposed to put in mind. I think up to there, we stop there. In our next session, we are going to discuss how to determine the shortest distance between the 2 points, like between point A and B. You want to get the shortest distance between point A and B. We have two ways in which you can move from A to B. You can move from A to B directly. That one is said to be along the parallel of latitude, or you can move from A to B along the great circle but through the North Pole like that. So that's what we are going to discuss in the next presentation. Thank you. Your presenter was Bright.